Hello and welcome to SkyRadar FreeScopes AI module. Let's start with generating some input data with signal generator. If I connect signal generator to a scope, we will have a constant signal. We can change the shape to a sine, and we can play with frequency, phase, offset, these things. So if we change frequency to 2 or 3, we will have it on a scope. Now I will add a noise block, and let's connect the noise block in between signal generator and a scope to have some noises, and let's reduce the level of noise to something like 0.6. So now we have a sine signal with a lot of noise, and if I change the frequency, you can see that. Let's have a bit more noise like this. Okay, now we have our signal. What we want to do, let's say we have different frequencies like 1, 2, 3 or 4. We want to train an AI network that can detect which of these patterns we have on signal generator after the noise block. So now let's start by recording our signal. I will connect a record and reply block here, and now we can record some data. Let's say we record something like 1000 frame for each of our patterns. Save, and let's rename it to something meaningful like sine, and this is frequency 4. Let's say F4, and then we'll change it to frequency 3, and again recording 1000 frames. Okay, pause, save, and again rename to sine F3, and let's do it with 2. Record, and again 1000. Okay, save to, let's name it this one, sine f2. Okay, now we have all data. We don't need signal generator anymore. If we play our data, it will be something same as what we had. So this is f2, this is f3, and this is f4. Now we can start building our AI model. We start with this one. This is our AI trained data setup, and here we will be able to select the input files that we have also here, and we can say we can filter them like this, and then selecting these ones. It will show us the list of files and allow us to set a label for each one. So we can say we have F2 here, F3 and F4. Any arbitrary label we can assign to our inputs, and then we connect this data setup to an AI input layer. In AI input layer, we should define the shape of our data. Here in signal generator, the shape is 200, so we just set 200 for AI input layer, and then we can have the definition of our model. For this one, we can simply say, okay, we have 2 dense layer. It should be enough to detect these 3 patterns, and we have 3 labels, 3 different classes. So we connect this one. We set the units of the last layer to 3, and we connect them together. This definition should be enough to detect the pattern. So no, it's not related to these ones. We are defining our AI model. Then we should compile it. Let's put it here. Compile. Then train. We can evaluate it after training. Save, and AI model end. We have to connect all of these ones also. Okay, and of course the definition of our model layers to AI compile. So here we have the inputs, here we have our layers, and here we have some normal definition of compile, train, evaluate, and save. Now by clicking here, we can start training. Okay, let's start training. It starts from here. Okay, To finish the training, it's defined 10 epochs, and with 99% of accuracy it could detect the patterns, and in evaluation also same, above 99%. We can change our properties, we can change our epochs. So let's say no, again we want to create, compile and evaluate the model with 20 epochs. If it make it more than 99.9, okay, 1, but not about the evaluation stay at 99%. That is good. So we have trained our AI model, and we have our model here, model out 8. Now it's done by these blocks. We can just put them away. We can clear it, because we have here another block that is AI trained model, that we can load or model out 8 here. Model out 8 load. This block is a trained model or trained model. We can connect it to, for example, or save data. Let's clear some of these ones. Okay, we don't need them anymore. We only have simply some data that we can play it if it's detected correctly. So this one, say F2, this is F3, and this is F4. Yes, so it detected correctly, but let's remove this and try with data that it never see. Instead of checking with recorded data, we can connect signal generator and noise. Frequency 2 is F2. Let's change to frequency 3. It's F3. It detected very well, and as we see, there are sometimes jump to something else, because it could not be 100% accurate. We can of course have 100% accuracy with this simple pattern with more data or more complex layers, but it's very good at 99% accuracy. And this is F4. If we give something that it never see, like 6, then it cannot detect it correctly, of course, because it never see a frequency of 6 of the signal, sine signal. But for the ones that we trained, like 2, 3, and 4, it's very good, very accurate. It can detect it. There are lots of layers here. We will add more in different AI modules, AI1, AI2, and there are lots of place for playing with AI. Thank you.